All righty, so we're halfway through this unit. 4.5 is solving inequalities that have absolute values. Remember, absolute values are never, never, ever negative. However, what's inside the absolute value symbols might have been negative. So that's why we need to remember there are two cases, just like our inequalities, there are two cases. So this is a real quick review. What are the possible solutions of the absolute value of x if it equals 6? And I have a little number line here. And if it equals 6, it could have been a positive, an absolute value of a positive 6. That equals 6. Or the second possibility is it could have been the absolute value of a negative 6, because that also would be a positive 6, right? Positive 6. Absolute value is the distance a number is away from 0, and it's always positive. But the inside could have been a negative possibility. So there's two possibilities for absolute value problems. Another little quick thing, absolute value of x that equals 9. So the inside can be either a 9 or a negative 9. They would both give us an absolute value of a positive 9. Steps to solving absolute value equations. Absolute value equations would be, whoops, I got a little typo here. I want to see if I can fix that, but I might not be able to. All right, absolute value equations are value. Eliminate or move everything on the outside. So remember, it's the outside of the absolute value symbols by using your inverse operations, because the absolute value symbols are much like parentheses. You want to get everything away from them first, and then worry about our two possible things, positive and negative possibility outcomes. Remember, there are always two possible values for an absolute value problem if and only if it equals a negative number once your absolute value symbols are isolated. If you do some math and try to isolate your absolute value symbols and your result equals a negative number, then you're done. There's no solution for that. Solve what is inside the absolute value symbols for both the positive and negative possibilities. And here are some examples. Number 1, we don't have anything outside of the absolute value symbols. So we know that the inside could equal a positive 90, or the absolute value of a negative 9b could equal a negative 90, because it started off equaling a positive number. So there is a possibility that the inside was a negative result before it was taking the absolute value of. So just forget about the absolute value symbols and solve. Negative 9b means it's multiplying, so the opposite of multiplying is to divide. So we've got b equals 90 divided by negative 9 is a negative 10. So that's one possible outcome. The second one, when we remove the absolute value symbols and divide, is to divide by a negative 9 again. And b could have equaled negative 90 divided by negative 9 is a positive 10. So on the inside of the absolute value symbols, we could have had negative 9 times a negative 10, or we could have had negative 9 times a positive 10. Whoops, absolute value symbols. And both of those would have given us the result of a positive 90. Both of those would have given us the result of a positive 90. Number 2, once again, there's sugar. There's nothing on the outside of these absolute value symbols. So we know that since it started off to equal a positive number, there could have been the off chance that it might have equaled a negative 74. So we've got two possible problems. So we've got negative 74 equals 7x plus 4, or we've got 7x plus 4 equals 74, and within the absolute value symbol. So just solve. Opposite of adding 4 is to subtract 4. So that gives us a negative 78 equals 7x. And if we subtract 4 from this one, we've got 7x equals 74 minus 4 is 70. We'll divide both sides by 7. Divide both sides by 7. And we get we get positive, or negative 78 divided by positive 7 is a negative, just 78 over 7. So that's all right, equals x. Or on this side, it's a much better answer. When we divide by 7, we get x, and 70 divided by 7 is 10. So this x value could have been the crazy fraction of negative 78 over 7, or it could be the nice number of 10. And either way, it would give you the absolute value equal to 74. Now, number 3, we actually have something on the outside of our absolute value symbols. And this negative 3 is outside of it and right next to it. That means it's multiplying. So we need to undo that first. So we'll divide both sides by a negative 3. We'll divide both sides by a negative 3. That goes away, and we have absolute value of x plus 5. And 27 divided by a negative 3 is negative 9. Is that ever going to happen? Can the absolute value initially start and equal a negative 9? And this would be no. It has to be equal to a positive number or 0 to begin with, or there's just no solution. This is not going to happen. So once this happens, we're done. We don't have to worry about it anymore. If it would have equaled a negative 9, then we had the off chance, or positive 9, then we had the off chance that the inside could have been a negative result to begin with, but this way we cannot. We're just done with it. All right, number 4. We have something on the outside of our absolute value symbols, and it's a negative 3. So we want to add 3 to both sides, add 3 to both sides. Now we have the absolute value of a negative 1p, and it equals 0 plus 3 is 3. So now we're starting off with a positive number. That means that we have the chance that it could have been a negative result on the inside. So we have to account for both possibilities. So we can just solve our two problems. Negative 3 equals negative p, and negative 1p equals 3. Both of them we're going to divide by a negative 1. Negative divided by negative is positive, so it could have equaled just a 3. And on this one, we've got to divide by a negative 1 as well. And this one says, well, it could have been a negative 3 on the inside of these absolute value symbols. Could have been a negative 3. And that's only because it started off with a positive number. And the last one, it started off with a negative number, and it just can't happen. It has to be positive to begin with. 2 more quick examples. Number 5 has 2 things on the outside of the parentheses, or outside of the absolute values. So the first thing we want to undo is the negative 6. We always want to undo subtraction or division first. And that goes away. We have negative 2, absolute value of x equals negative 10 plus 6 is a negative 4. Once again, like number 3, if a number is right outside the absolute value symbols, that means multiply. So the opposite of multiply is to divide both sides by negative 2. And now we have absolute value of x equals a negative divided by negative is a positive. And so this can happen. This is a good thing. If when we get our absolute value symbols isolated and it equals a positive number, that means there's an opportunity for the inside of the absolute value symbols to be a negative result. And this one, there's no more math. You've got x equals 2 or x equals a negative 2, and it's done. Last example, there's nothing on the outside, and it's equal to a positive 8. So that means it could have been a negative 8 on the inside of the absolute value symbols. So we've got negative 8 equals x minus 5, and x minus 5 equals a positive 8. Add 5 to both sides. And we have negative 8 plus 5 is a negative 3. So x could have equaled a negative 3 on the inside. And over here, we'll add 5 as well. And 8 plus 5 gives us 8, 9, 10, 13. So that means x could have been a positive 13 on the inside of the absolute value symbols. Either way, once you take the absolute value of those numbers and do the math on the inside of absolute values, you would come out with a positive 8. And we are